Okay, these are all about linear approximation. They give you f of 25, and the function value is the y-coordinate that corresponds to the x-coordinate of 25. So you're starting at a point of 25, 10 on a graph, right? And they tell you that the slope, right, which is f prime of 25, is -2, right? So that means that for any change in x of 1, right? So if we move over 1 from 25, which would get us to 26, the y-coordinate would change by -2, right? So I'm actually going to start with part B, right? At 25, 10, right? If we step over one space on the x-axis to 26, we would go from 10 down 2 to 8. Right, and then from there it's easier to build off of that and say, okay, if we go from 26, 8, and we go over another spot, we're still using the same approximation. Obviously, the further you get away, the worse your approximation is, but as long as this is the only information we have, we're going over another one, and so we're going to go down another 2, so that is 27, 6. Alright, now in part C, right, if we're only going over 0.25, so we're not going all the way over to 26, but if we started back at 25, 10, right, and we know that we lose 2 for every 1 that we go over. For if we went over 0.5, we would only lose 1, right? So we could have had this point, right? 25.5 would give us 9, right? But since we're only going half of that, 25, 10, only going over by 0.25 spaces, right, would get us to 9.5, which is just 0.5 less than our original value. Now, the last two, for parts D and E, we're actually moving our way backward, right? So instead of losing 2, when we move to the left, we're actually going to gain 2, right? So instead of 25, 10, we're going to go to 24, 12, right? And from that point, right, so 24, 12, right, we're going to move back another 0.5 spaces, but for every 0.5 spaces, we move up 1, right? So 23.5, right, would be 1 higher, so that would be 25, 13.